Since it looks like we're going to be calculating lots of areas and doing even more abstract stuff, it's often helpful to establish some quick approximations or kind of put up some guardrails so we know if our final answer is just way off track. So let's talk about how to do that. How could you give me a quick answer, kind of as simple as possible, about how far this person drove in these 4 hours? Well, one way you could do it is you could say, I'm going to have an upper bound, and I'll do this in blue, I guess. So an upper bound is a number that is definitely bigger than the number that you're hoping to get for your very detailed, precise answer. What's a way to get an upper bound on the total distance traveled here? Well, you could say, pretend that the person drove 60 miles an hour for 4 hours. So I'm going to draw a bar or a line up here, and that would be 60 miles per hour for 4 hours. And what is 60 times 4? 240. So I'm pretty sure that the answer I get should not be bigger than 240. What's the opposite of an upper bound? It would be a lower bound, which we'll do in red. Can you give me a quick lower bound on how far this person drove? Well, there's actually two quick lower bounds. One is super quick. I could pretend that the person drove 0 miles an hour for 4 hours. So a super quick lower bound would be 0 miles an hour for 4 hours, or 0 miles. It's quick and easy, right? Can you get a better lower bound? Well, you could pretend that the person drove 40 miles an hour for all 4 hours. So this is giving me my lower bound. This is giving me my upper bound. So a better lower bound would be 40 times 4 hours, which is 160 miles. So if I did all my fancy precise work and got an answer less than 160, I would know that, wait, something had gone wrong, because I put a lot of faith in this estimate. It's just a simple multiplication. So is there anything better we can do, or that we can do with this upper and lower bound to get hopefully an even better answer? Well, you might say, let's have a guess. And I'll do that in purple, because that's kind of the average of blue and red, right? So a guess might be our lower bound plus our upper bound divided by 2, average the two of them. So that would be what? 160 plus 240 over 2. And can we interpret the guess visually? It's the average of these two rectangles' areas, but the rectangles have the same width. So it would also be the average, using the average height between the upper bound and lower bound. So I'm putting a box there. Pretend these lines are all at 0 and these lines are all at 4 hours. So I'm hoping that the true answer is closer to my guess than to the upper bound or lower bound usually. So this kind of quick approximation or guardrails is something that most calculus professors don't teach, and it's good practice on the homework as you're going along. It's not absolutely mandatory, I suppose. But one downside to it is that it gives us a set of numbers to check our final number against. But calculus isn't all about getting final numbers. It's about understanding how change is happening through time and stuff. So it's good on problems where we're supposed to get a final number. And the general idea of upper and lower bounds is good in math in general. But we don't want it to make us think so much about static problems where it's just like, I have to estimate this area, when in fact there's lots more interesting stuff going on with calculus and change in time and stuff. So don't let it take over your thinking.